Hi, everyone. Welcome to this edition of Problem Solve Supply Chain Edition. I'm Dr. Lutz, and in this episode, we'll be going over project management. Specifically, we'll look at the tools of a work breakdown structure, Gantt charts, network diagrams, and then using those network diagrams to do the forward backward pass, identify slack, and calculate your critical path. So we'll start off first with a definition of project management. So project management's the process of planning, organizing, and managing tasks, people, and resources to complete a project on time. So basically, project management can be used for big projects that we think of, like building a brand new stadium, or you could think about it, you're planning a party. But I want you to realize that it can be used in our day-to-day lives with something like planning a party. If you think about a wedding, might be something most people might be involved in at some point in time. That is a big project that you have lots of different activities that you have to manage to make sure it all comes together for that successful event. But even if you're planning a small party at home, you're going through a lot of those same steps. So regardless of what you do, project management is a useful skill. So the tools that we're going to look at are a work breakdown structure, the Gantt chart, and network diagram. So we'll start off first with definitions of each. The work breakdown schedule is basically just the list of all the activities that have to happen for your project to be completed. Also, you're going to have the estimated time or duration that it's going to take to complete that project. And you're also going to explain any relationships that there are between different activities. So you want to make sure that those bigger tasks are broken down into smaller steps. And you want to be specific about what it is. So if you miss some steps, it could cause problems at the end because it might delay your overall project. A Gantt chart then is a horizontal bar chart. It's going to give you an idea of how long is it going to take for your project to be completed. So the Gantt chart will not specifically show you those relationships, but it will be able to tell you the project duration and what activities can happen or should happen at the same time. The other main tool that we're going to be using today is a network diagram. That's going to be a visual representation of your project where the relationship is going to be clear between those activities. So we're going to use what they call activity on node. So we're going to have a node or a circle representing the activity and then the arrows representing the relationships between those activities. So you want to make sure that you draw this correctly, get things in the right sequence, and show all of those relationships. So we're going to start off with an example here. So in this case, I've created a project and the main activities that have to happen are activities A through H. So most of the time in project management, we would have activity A means that we are reserving the room. I don't know what it would be, but you would have a description, but as we're going through the tools, we usually represent each activity as a letter. We have the predecessor, or that is an activity that has to finish before that next activity can start. And then the duration or time, in this case, I have it done in weeks of how long we estimate each activity is going to take. So if we look at activity A, it says it has no predecessor. It's going to take 1 week. Activity B, though, has A as its predecessor. That means A has to be completed before activity B can start, and then it's going to take 4 weeks. And we just keep going through that. So the next thing we're going to do then is draw our Gantt chart. So again, horizontal bar chart that represents those activities. I'm going to start from the bottom and go upwards because I'm never good at estimating the amount of space I need. Some people are really good and can get it perfectly. A lot of times you will see it represented from the top to the bottom. Honestly, I don't think it matters. Some people it really might, but this is just what's easier for me to do. And the other thing you'll see me do is at the end of each bar that's representing the activities, I will show the duration because I am not good at drawing these and it will not line up usually with the lines at the bottom. All right, so we're going to start here. Activity A takes 1 week. So I'm just going to draw that here. So we have activity A and it takes 1 week. Then we just keep working through. Activity B has A as the predecessor, so A has to be done. So that means B can start at time 1, and it's going to go for 4 weeks. So it would be done at time 5 there. All right, next we have C. A is its predecessor, so again, it can start at time 1. It's going to go out 3 weeks, so to time 4. So this is C, and it would be done at 4. Next, we have D. It has B as its predecessor, so D is going to start at time 5. It goes out 2 weeks, so that's about 7. All right, E has C and D as its predecessors, so that means both of them have to be done before E can start. So C's done at 4, D is done at 7, so the earliest E can start then is at time 7. And it looks like it's going to take 5 weeks, so that's 12. So that's about here. This is where I was saying I don't line things up perfectly, so that's why I put the time there. All right, F has D as its predecessor, so again, it's going to start at time 7, go 2 weeks, so out to about time 9 there. So that's 9. G has F as its predecessor, so it's going to start at time 9, go 2 weeks to time 11. So didn't leave much room for there, but we got it. And then H is going to have E and G. So E's done at 12, G is done at 11. So it's going to start at 12, go 3 weeks. So that was H, and it'll be done at time 15. All right, so that is your Gantt chart, horizontal bar chart. It shows us how long our project's going to take. In this case, our project is going to take us 15 weeks to complete. We can also see certain activities like B and C and E and F are going to happen at the same time, but it does not clearly show the relationships that we can kind of guess at what they are by where activities start, but it doesn't clearly show the relationship between those activities. So that's where the network diagram comes in handy. So we're going to use the same example again for the network diagram. I'm just going to change our color here to black. So what we're going to use is we are going to have a circle for our activity. So I will just kind of draw it up here. So we'll have an activity. And then you're going to have the duration as a subset. And just imagine that as a circle. So that's what we're going to do. So we're going to have activity A is our starting one. I'm going to put it over here. It has a duration of 1 week and it's in a circle. One thing to note is that we usually go from left to right and we go kind of horizontally. We're not going up and down. Ideally, our lines won't cross. If they do, I don't really worry about it. For some people, it's a big deal. All right, so next we have B. It has A as its predecessor, and it's going to take 4 weeks. I'm also going to purposely leave a lot of room around these because we're going to come back and draw on this network diagram for those forward and backward passes. Okay, so then we have activity C has A as its predecessor with a duration of 3. All right, D has B as its predecessor, so I'll put it up here with a duration of 2. E has C and D as its predecessors with a duration of 5. So what you'll see is there are 2 arrows coming into it because it has 2 predecessors. F has D as its predecessor with a time of 2. G has F as its predecessor with a time of 2 again. And then finally we have H with a duration of 3 that has E and G as its predecessors. All right, so that is your network diagram. If it's something relatively simple like this, we can use this to figure out how long your project is going to be, that we can identify every path through there. So we could go A, B, D, F, G, H, and then we can add together to the durations. That's part of the reason I like to write the duration in the circles. So we have 1, 5, 7, 9, 11, 14. Hopefully, I'm doing my math right. We could also go A, B, D, E, H. So we're just following the different paths to get from A to H. So that's 5, 7, 12 plus 3 is 15. And then we have A, C, E, H. So that's 4, 9, 12. So in this case, it shows us that there are three different paths through the network, and we're going to choose that longest path as in terms of our project duration. And if we go back to our critical path, that's exactly how long we said it was going to take. So we can also find the project duration from the network diagram. What we're going to do now is look at some ways that you can use the network diagram to figure out a little bit more information about your project. So in order to do that, we're going to talk about the forward and backward paths and slack. So I've tried to make up formulas here. This is what I share with my students as ways to kind of keep it in mind. So the forward pass is going to be, if we look at this graphic up here, the numbers on the top, the early start and early finish. And then the backwards pass is when we're going from the end back to the start. We're going to calculate our our late start and late finish. And finally, we have slack. So you have these rules here, and I'm going to explain them just as we go through it, but I wanted you to have a resource to look at as we do this. And slack, you'll see I'll eventually put up in the center here so we can see it all at once. All right, so we're coming back here. What we're gonna do, I'll kind of use the colors I used on that last slide. So we'll use green for our forward pass. So for any starting node, your early start is 0. So again, right now we're doing early start and early finish up here. You're gonna add to it the duration to get the early finish. And so that would be 1. So this is telling us activity A, the earliest it can start is at time 0, and it's gonna finish in 1 week. This number here then is going to move over and become the start for those relationships that it is tied to. So if there's one predecessor, the early finish for that predecessor becomes the early start for that activity. And we'll look at like what happens here for E later. But then once you have it, the early finish is just that early start plus the duration. So 1 plus 4 is 5. 1 plus 3 is 4 here. So again, B is going to be done at time 5. So that's the earliest that D can start. Oops. And it'll be done at time 7. All right, so if we go to E then, it has two predecessors. So we are looking at D and E, because that's where the arrows are coming from. And what you're going to do is choose the largest number. So if you think about when we drew that Gantt chart, we said both of those activities have to be done before E can start. So if C is done at 4, D is done at 7, that means E can't start till 7. Then you're going to add the 5 to it, so it would be 12. All right, over here we have 7 plus 2 is 9. I'm just going to kind of sneak through these since they each have 1. And then again for H, it has two predecessors. So we're comparing this 11 and 12. And you're going to choose the larger number. So 12 plus 3 is 15. So the forward pass through that network actually gives you the project duration. So we can see that this project is going to take us 15 weeks to complete it. What we're going to do next then is that backwards pass. So again, it's on the slide here. We're going from the finish to the start. So now we're going and following it backwards to the start. So you'll see here I call them connections because we're following that path backwards. So it's not really the arrow anymore. But in this case, if we come back here, what I said on that other slide is that if you have one ending node, that late or early finish becomes your late finish. So this project would be 15. If there were multiple ending nodes, you're going to choose the largest one, and then that becomes the largest early finish becomes the late finish for all of those nodes. What we're going to do then to get the late start is subtract the duration. So 15 minus 3 is 12. So again, I'm calling these connections because we're kind of going this way. So if there's one connection like to G, it's gonna, late start is gonna become the late finish. So it'll be 12 minus 2 is 10. There's one going backwards into F, so that's 10 minus 2 is 8. And again, there's one going into D here. So if we follow that back, or no, sorry, there's two going into D. I was getting my arrows mixed up there. All right, so we have to do E here. Again, it's one connection, so this is 12. minus 5 is 7. So D has two arrows coming into it, the reverse path. So kind of this way, if you think about it, what I'm calling those connections. So we're going to look at those two late starts, and on the backward pass, choose the smaller number. Because what it's saying is that the latest that E can start is at week 7. The latest that F can start is at week 8. So if we need them to start on time, we're going to choose that smaller number. So this would be a 7 minus 2 is 5. So again, down here to C, there's one connection. So it's 7 minus 3 is 4. Up here, one connection, 5 minus 4 is 1. So again, for A, there's two of those connections kind of coming this way. We're going to choose the smaller number. So we're going to choose 1 and 0. All right, so that is your backward pass. If you did your backward pass there correctly, there should be one starting node in case there's multiple ones that has the 0, 0 in order to complete it. The next thing we can do now is calculate slack. So slack is going to be the amount of wiggle room, kind of fudge time you have at that activity. So it's going to be calculated as either the early start and late finish. Let me just choose a color here. We'll go to purple, something totally different. So it's either these two or these two numbers. So think of slack as you're looking at one side on that circle. So we're not going across them now. We're looking up and down. And again, basically slack's going to tell you how much wiggle room you have, how late that activity can start for the project to still finish on time. So slack, we're going to draw in the kind of that top center of them. So again, we're looking at either side here, but in this case, like if we look, 0 minus 0 is 0. And again, shouldn't matter what side, they should be the same number. If they're not, you did something wrong. But again, 1 and 1 and 5 and 5, so that's a 0. 1 and 4 or 4 and 7, the difference is 3 there. Here we have 5 and 5, so it's 0. 7 and 7, it's 0. 7 and 8, so this is 1. 9 and 10, that's a 1. And this one should be 0. So again, you should have one ending node that has all the same numbers as well. All right, so Slack then tells us like activity C in this case can start up to 3 weeks late. And as well, as long as everything else goes according to plan, that project is still going to finish in 15 weeks. The thing to note is you cannot add Slack together. So we can't go, there's 3 weeks at C, 1 at F, 1 in G, so I have 5 weeks of Slack. Doesn't work that way. Slack is relative to that activity that we are looking at. All right, so if we jump up here, the next thing then is your critical path. So your critical path is going to be the longest path through the network, which is then going to tell us that that's the shortest amount of time to get all of those activities complete. So if we come back here, one thing it said on there, I kind of skipped over it. There's no slack on your critical path. So once we've done that forward and backward pass, you can actually use this as a way to identify your critical path. If we follow those activities with 0 slack, we have A, B, D, E, H, and we know that's going to take 15 weeks. So this is your critical path. So if we have a small project like this one, it's not a big deal to go and calculate all the different paths through the network. But sometimes, and I'm just going to write that down here as a reminder, there's 0 slack. If you have a lot of different paths through it, it might not be as easy to calculate all those paths. And that's when this forward and backward pass comes into play and makes it a bit easier for you to find that critical path. All right, oops. So basically, again, project management, set of skills. You use them pretty much every day, but we're just kind of putting formal terms on those to help you plan, organize, and complete a project. So this video went over work breakdown schedules, Gantt charts, and then using network diagrams to do that forward, backward pass, calculate slack, and the critical path. So if you want to see more videos like this, subscribe to my YouTube channel. And also, I do have a textbook out there. So that's it for today. Thanks.